Alright, it seems we are live. Okay, so let's continue where we left off yesterday. What were we doing yesterday? To do, yeah, this thing. I think if we have arcs, then create the corresponding. Wait up. I think we already completed this task, right? If we have arcs, then create the corresponding. Yeah, I think we have already completed this thing. Or have we? No, let's see. This is in the compile subroutine. Parameter list. Yeah, right. We have already taken care of it. So let me delete this to do. Nice. Okay. We have to do this and create a tag for index. Yeah, won't need this to do anymore. Yeah, we need this to do, and we were here last time, so let's see what we need to do. You know what, what's the grammar? What's the freaking grammar part? Lexical elements, program structure, grammar. Yeah, grammar. Okay, so let's take care of the subroutine call thing. Subroutine. Let's check the methods. Compiling constructors and compiling method code. This is the caller code and the poly code. Alright, so caller will be something like this. Ooh, wait up. Instead of p1 we can have class here, right? So this is a variable object. Okay, Is it going to be an object only? I need to check the grammar. Subroutine name. So either the subroutine name appears without any class name or variable name, or it appears as with class name and a variable name. But only the constructor will be called using the class name. Well, it doesn't matter, does it? Not? It doesn't matter, I think. But what does matter is where are we right now? We are inside compiled. All right. And why are we writing the right call here? What the hell is this? Yeah, this is the subroutine code, right? Yeah, please. It is the subroutine code. Object push x1, push x2, and call foo. Call distance. All right. So in case of methods, the name will be, the function name will be just the function name itself, the subroutine name itself in this case. But let's see, compiling the method calls and compiling the constructor call. What's the code for the constructor call? Where is it? Caller, yeah, to say. So in case of constructor, it's going to be point.new. Holy shit. Okay, it fucking doesn't matter. In any case, see, if it is a method call, we need to push the object as into the on the top of the stack. So right, that's the object. So according to grammar, it will be before dot. What is it? Yeah, it is here. Current class name or a subroutine name. Yeah, right. So we need to construct a method variable, the subroutine variable somewhere. So in case it is a class, we need to append the class before dot. Right. Wait, does it take into account when we have a variable? What's the grammar? The variable class name and the variable name. Yeah, right. So let's see. Terms, print the token and check the token type. If it is an identifier, name is equal to token, kind of the token. It will fall into this category. And we need that freaking token, right? Wait, it seems we have a bug. What if we have a variable name dot subroutine name? Let's see what happens in the present code. First we print that token. So we print variable name. Now we check if it is an identifier, which of course it is. So we save it as a name token and we call kind of. Well, because it is a variable name, we are going to get the kind of token, right? Yeah, right. And it will go inside the else loop. Wait, yeah, just take care of it. We're going to push it. We are definitely going to push it, right? But what will be the type? Let's see. Does it matter? Where is it? Where is it? It falls into place very nicely. So let's see. Push object. Push object. What is object? What the hell is this object? Let's see. Well, in this case, p1 is a variable of type point. Yeah. So it's a local variable. Okay. Nice. Okay, this is complete. This is perfect. So we are already pushing the object on top of the stack. Great. So now all we need to do let's go back to grammar. So we are already taking into account if it is a variable name, right? So variable name is being taken care of, but what if it is a class name? Well, then we don't push it onto the stack, right? Of course. But here when we call this right call, we need the subroutine name, right? So let me uncomment this shit. So we'll pass. So what do we need to pass? What do we need to pass? What's the freaking code? The API. Yeah, we need to pass the name of the function as well as the number of arguments. Yeah, right. So we'll pass func name and an args, right? But it will be different for different cases. So first of all, let's retrieve the function name. So let me check what kind of cases we have. So in case of a subroutine call, we will be having three cases, right? Either it is just a subroutine name, or it is a class name dot subroutine name, or it is a variable name dot subroutine name, right? So if it is a subroutine name, the function name will be just that, the subroutine name. And I should call it, instead of function name, I should call it subroutine name to be consistent. Call it sub name. Yeah, this is a sub name. So in case of subroutine name, it will be just this sub name is equal to subroutine name. That when we have a class name dot subroutine name, in this case, let's see, yeah, the name should be class name dot subroutine name. But when we have a variable name dot subroutine name, it's just going to be subroutine name, right? So first of all, we need a subroutine name variable. So let's create it here. Subname equal to, let's keep it blank. And when we have a class, what we are going to do is append the class name. First of all, where's the class name? It is in the name token, right? Yeah, it's going to be in the name token. So what we'll do is sub name equal to name token. Yeah, right, this is correct. And we'll also append a dot. After that, well, if it is just a subroutine, yeah, this is just a subroutine, right? Why can it be just a subroutine? Now, when it is just a subroutine, what we'll do is subname equal to name token, and in this case we don't need dot, or subname will be just subname. Right, so we have taken care of one case. Hey Janice, welcome to the stream, man. It's good to see you here. How are you? Subname is equal to name token. In this case, we also need the subroutine name, but where is it going to be? If token is equal to this, and if it is this, is it going to be this one, the subroutine name? So we have already fetched the subroutine name in this case, but now we need the subroutine name in this case, in the class name and variable name, and it's going to be here, right? The token is integer constant token dot advance. This, either this or dot. If it is this one, if it is a dot, then we'll have this case, and this token after that. Wait a minute. Are we not printing this token or what? Yeah, we are printing the token. It's cool, that's cool. After that, we advance the token, we get the subroutine name. Yeah, this is what we need, the subroutine name token. So let's see, we can do sub name equal to and plus equal to token. So what this will do, wait, should I, let's, yeah, this is all right. Sub name is plus equal to, so why have I written it like this, plus equal to? Because in case if it is a class name before this subroutine name, we already have the class name in the subname, so that's why I have written plus. But if it is not a class name, if it was a variable name, the subroutine subname will be just empty string and will append the token, which is the subname. Alright, so we have got the subroutine name in all the cases, and all we need to do now is call the subroutine name. Yeah, but now we need to take care of the number of arguments. How are we going to take care of the number of arguments? Number of arguments, let's see, we need to count how many arguments there are. Yeah, so what we can do is, when we call, are we calling the expression list, subroutine name, and after that we have an expression list, right? So it is just after this thing when we call the expression list. So the expression list determines the number of arguments, right? And how can we fetch the number of arguments? The expression list should return the number of arguments, or maybe we can create a logic here to count the number of arguments. Can we do we can make this compile expression list to return the number of arguments. It will be easier that way. You don't have to write a lot of logic that way. So let's go into compile expression list. Expression list. Let's say, so in the while loop, let's create a variable here called number of args. It will be 0 initially with the token, and see, after we are done writing, we'll return an args. So what happens if there are no arguments? It will return just 0. But if it goes inside, if token is not equal to this, then we will go inside this loop, right? First expression, after first expression will increase this variable, increment the variable. This will be the first expression, first argument. The second and so on will be inside this loop. We'll again increment and args equal to 1. Okay, this logic is correct, I think. Right, and finally we'll return the an args variable. So let's go back to compile, done. And when we call expression list here, we'll get the return value in the n args, right? But there's one case when when it is a variable name, right? When it is a variable name, we should increment the n args by 1, because you also have the variable name as one of the arguments. So what we'll do here is we'll create the n args variable here, and args, it will be 0 initially, and let's see, we need to increment it when we have a variable name dot subroutine name. Where are we going to increment it? This is a problem. Okay, so let's write a condition here. What should it be? Oops. Check if the call is of type where name dot sub r. Yeah, so if what, if kind token and yeah, you know what we'll need this thing. And let's not call it token here. Should we call it well, you know what, we can even get rid of this code, right? This will be enough. We get the token here, we advance the token, get it in token, and we again revert it back. So we already have the token here, we don't need it here. So let's delete this. And now we can use this token here as well. Now here we need to check if toke equal to dot. Yeah, this is correct. If the kind is given and the token equal to dot, that means it is a variable, it is of type variable name dot subroutine name, right? Yeah, definitely. Because if it is a class name, we won't have the kind token, right? So now we can do an args equal plus 1. Awesome. And we have taken care of everything, I think. And now we can call subname and args. So let's delete this to do, we don't need it anymore. Okay, since we have written the code for what? Calling for the callie part of the objects. You know what can be now? Wait, have we written the code for the return part? For the return expression? I think we have not. Anyway, let's try to get the code for this thing. Let's see if it works or not. We need to close the file as well. We need to call self.bmw.close. Where are we going to close it? Let's see. When we reach the final statement, what will be the final statement? Will it be the return one? Yeah, I think it will be the final one, mostly. Will be having return in all of the cases. Let's check an example code. We have a return here, but wait up, we will have multiple returns, right? If we have two methods here, a constructor and a simple method, we'll have two returns, so we can't call close on the first return, right? So what do we need to do then? Do we need to close it? Will it give us any error if we don't close it? If that is the case, we can't have VM writer. We can't create the VM writer here. We'll have to create VM writer in the check analyzer and pass the VM writer to the parser. I think it will be better that way. Yeah, right, it will be better that way. So let's get a VM writer like this. VM writer, and we need to pass the path which we already have here. What we'll do here, from VM writer import VM writer. Okay, this is nice. And what we can do here is pass VM W to the parser. Now let's also modify the parser. After the sim tab, we'll have VMW, and instead of this thing, let's directly assign VMW like this. Now what we can do is wait here, after all we have exhausted all the lines, where does it happen? See, check tokenizer, sim multiple VM writer. Yeah, right. So yeah, we can call vmw dot close here, right? Let me check VM writer. Do we have the close? Yeah, we do have close. Okay, so I think this is going to work. Okay, let's try to run it. Right, how do we run it? That's the check analyzer dot check analyzer, and we need to pass eleven 7 main dot check. Yeah, right, we only have main dot check here, right? Don't have any other files, so let's call the check analyzer. Whoops, what happened? We have a syntax error. Of course we have, because let's go back in the whoops. If end, yeah, I forgot to, every time I forget to write the formatted string. Could be like this here as well. Great, we're using it only twice. Okay, nice, nice, nice. And we need to change while end as well. Okay, we won't have the error now. Let's try to run it again. Oh, great, it ran without any error. But do we have the output? It should be inside 7. Yeah, we do have. Wait a freaking minute. Yeah, we do have main out.pm. So let's check it. We have a push const on. Wait up. It should not be push const on. It should be in the lower case and it should be constant. So we need to modify something. Let's see. Const const. Yeah, here. That should be constant, not const. Where else do we have const? Okay, let's try to run it again. Oops, what happened? Yeah, not this one, this one. Okay, we have constant now, and we need to change this as well. Instead of capital add, we need to have a lower add. Let's check. Yeah, that's the problem. We're calling. Let's check VM writer. Where's the right? Oh yeah, yeah. All of this should be in lowercase. What was this one again? And or this is LT GT EQ, right? Oh no, fuck no. I closed it. Fuck, I need to open it again. And I didn't lose. Yeah, I didn't lose the buffer indexes. Those are correct. Right, so now try to run it again. Push constant 1, push constant 2, push constant 3, and we have add. Right, but is this the correct output? Seven dot check class main function void main do output print ln. Oh right, we don't have, of course we don't have, we have not written the subroutine code or do, that's why we don't have it. But yes, we still have 1, 2 and 3, right? So let's write the subroutine code for the do part as well. Can we directly copy it? Let's check. What was I going to do? Yeah, compile do. Oh come on. Yeah, this here in the subroutine name. Yeah, I think the code is going to be almost similar. Wait, is it going to be similar? I don't think so. Yeah, it will be similar. So all we need to do now is just copy it. Compile do is at 520. Compile DOM. $722. Okay, first of all, let's copy subname and enarx. Y20. Oops. Yeah, right. Y20. Paste it here. 722. Now we need to copy, let's see, this part. Yeah, let's copy this part. And go back to Y20 and should we paste it? It should be here. Net. And one more thing, we don't need this here now. Okay. Python 2. And 20. How can I move back and forth between these two lines? I think there is a functionality in Vim to do that. Is it marker? That doesn't matter. Okay, let me try to find it. How to move between, no, not how to go, how to jump between two lines in a file quickly in Vim. Fast switching. You can use bookmark, something like an A, to mark a bookmark name A, and then dot. So is this dot or a code? To go to it, naming the box A and B, for example. Let's switch between. Awesome, this is exactly what I needed. So let's create a bookmark here. M. Did it create the bookmark? Yeah, it did. Awesome, awesome. This is exactly what I needed. Now let's jump to 520 and create a second bookmark here. M B. Great. Now let's see if we can jump to A. We can. Great. So now we need to copy and close this. Yeah, what do I need to copy now? Copy this part, and I copied this. Let's copy this as well. Ooh, nice. Okay, let's go back. What do I need to copy now? Yeah, this part, subname. Also copy this. Okay, where should it be copied? Yeah, yeah. Was this the right place? I don't think so. What the freaking hell? It was the correct place. Okay, I need to indent it properly. Okay, this is correct now. I need this code now. Yeah, right. Let's copy it from here up to this part. Yeah, let's copy the VM writer code. Should be pasted. I think it should be pasted here, right? I think this is the correct. Yeah, this is the correct place. Just need to re-indent it properly. Okay, it's correct now. Right. Now, so I have copied VM code writer up to this point. And what do I need now? Yeah, I don't have this part as well. So yeah, first of all, let me create a new bookmark here. And okay, now let's copy this to, yeah, this part. Nice. Wait up. This is Aleph and this is else. This is not right. This should be Aleph as well, right? Ooh. I think I have a messed up indentation. Let me go back to B. Was it B? Something is not correct here. No, we don't have an if part here. Why is that? Wait, how is that possible? We are not checking if the token is an identifier or not in this case. Okay. Why is that the case? Man, this is messed up. Token is this. If else token else. Okay. Oh, yeah. So let's go back to the it seems we don't need this. We don't need this alpha part. Of course we don't need it. It's not going to be an integer. We don't need this thing here. Need electric. This is unnecessary. Right. So let's go back. But what we do need this part. We need this part. Copy it. Should it be copied? Okay. Wait, where is it? Okay, I think it is going to be here. Right? Yeah. We also had sub name up here somewhere. Yeah, we copied it already. Now we copied this thing. What's remaining now? Yeah, this VM code. We need to change compiler coordinates. Instead of this, we'll have this. Now I need to copy this part. This is the final part. Right. Wait, why don't we have an if here? Well, I guess it doesn't matter, let's just copy it. Okay. Good. I think the code is correct now. Okay, now we need to test it out. Let's do that. Right. Okay, we have the output. Push constant 1, push constant 2, push constant. Wait a minute, we don't have. Yeah, of course. Because it is a multiplication symbol. You only have add. What should be the output? Let's check. Yeah. You open up a new. Tab, okay. CD and project rules. Projects 11.7. Dot check. And how do I move between these windows? Hey Jan, that pressed that. Yeah, I gave it myself. Because of COVID, I can't go out. That's why I did a self haircut. Not exactly a self haircut. I had some help, but yeah, it was totally homemade haircut. Yeah, I do. Don't I? This is the first time I have tried this haircut. How is your cursor? What cursor? It's awesome, man. I like it. Yeah, I love it. It doesn't get into the way when I'm, in the insert mode. So I love it now. How did your interview go? Skip. Whoa. What? How, how can you skip an interview, man? Why would you do that? Laziness. That kind of laziness. How did you get that interview in the first place? Did you reach out by yourself or did they reach out to you? You up. You dumb. So you applied and you didn't show up for the interview. By the way, I forgot how to move between these windows. Yeah. And the call and schedule. Where did you apply? On LinkedIn or any other site? Why? But why? Why didn't you? Why did you skip it? Fuck, man, fuck. How can you skip an interview? LinkedIn, right? So if you didn't want to interview, then why did you apply in the first place? Rin, push constant 1, constant 2. Tell him not to, but why? Didn't you like the role that they were offering you? How was it a bad decision? I mean, what could have gone wrong? I mean, they could have rejected you. But was telling not to. But why? Don't you want a job? But don't you want a job? Just the feeling, yeah, but then what the fuck, man? Even if they had rejected you, you would have gotten the, experience. Are you crazy? Lol. Why are you making excuses? Tell me the real reason why you didn't apply. What was the role like? What was the job description? What the fuck? It should be... Yeah, this is correct. Told you the reason. Who makes decisions like that, man? On the guts? Still, but what was the role like? What was the description of the job? What were they looking for? Software engineer, yeah, that's a very broad term. What kind of software engineer? A backend, a front end, not a front end. Person who knows. Damn, man, I would have loved that kind of job. A role which requires only Python. Did they require any other framework or libraries or, backend, not backend, like database stuff and JS? Oh, that's awesome. And Git, Linux. What the hell? So if they require JS, I think they might be looking for a web developer. Well, maybe. That's a nice role. I mean, Python, JS, Git, Linux. Clearly, they were looking for a beginner. You would have gotten it, you know. And where does this company? Where was it from? Was it from Ireland or from somewhere else? If it was in your LinkedIn, I think it must be in Thailand, right? Because they do this location-based job or thing. You're not sure? So before applying, you didn't even inquire into this kind of stuff? What the hell? You sure make decisions on the fly, don't you? I forgot about it. Yeah, it's okay. So, yeah. I mean, you could have gotten the, experience even if you didn't get the job. It doesn't matter. There are many jobs. Don't do that again, okay? And if your gut doesn't allow you to, then don't even apply. Where was your gut when you when you were applying? Didn't he tell you something? Yeah, don't do that again. Don't listen to your gut smell. Listen to logic. Applying was a run through. Yeah. It doesn't matter. You didn't lose anything, so. Yeah, too much issue. You have to think it out. So what, did you just chickened out? You didn't even tell them that you don't want to? You just skipped it, right? You wasted that time. You should have at least told them, that you are not going to go up for the interview. Yeah, it is definitely a mistake. I mean, what's the gut anyway? I mean, the gut doesn't tell you anything. It's just your mind telling you to do something. So if it is your mind telling you, I mean, you have to figure out the logic, Why is it telling you to not do something? Yeah, it does. I don't know. There's no. What do you mean when you say your gut tells you something? I don't really get it. How can your gut tell you anything? The thinking part is all the mind, not the gut. Gut can only crunch the food. Yeah, we are definitely different, but yeah, I don't get it how people can make good decisions. I mean, maybe I'm born. Yeah, I mean, yeah, people are different. Yeah, of course, I can compare you. Definitely, your mind works in a different way. But when people say, they make decisions based on gut, I don't really get it what they mean. Like, how can your gut tell you something? What do they mean exactly? Feeling, yeah, right. I mean, feelings occur in the mind, not in the gut. That's what they really mean, right? When they say they have a gut feeling. Yeah, I don't have that kind of gut which tells me something. I do have a mind which gives me feelings. And in terms of feeling, I have very different feelings, you know. If I listen to my feelings, definitely not gonna move anywhere. Because my feelings, you know, swing like within a second. Yeah, you can call it intuition as well, right? Yeah, you can call it intuition. So intuition is kind of when most people say they have a gut feeling, mostly they mean their intuition. So yeah, you can through experience, you can, I don't know what do you call it. You can have a lot of intuition if you have gone through many experiences. But I don't think you have gone through that many experiences of interviews. Have you? Have you? It's not that. It is definitely that. Let me try to Google it. What what does it mean to have a gut feeling? Psychic messages. What the fuck? I'm not gonna open this shit. Scientific explanation. Yeah, that's more of a logical thingy. What's this? Dr. Chopra, who the fuck is this? I mean, yeah, maybe you can't explain it, but at least we can have a logical discussion regarding it, right? What's a gut feeling anyway? Every time I get this term feeling, I think of the capstone post. So that every cell in your body making a decision. Now, this is a good explanation which we can, you know, uncover. Every cell in your body is making a decision. That sounded like a little too much fairy dust. Yeah, it sounds like a fairy dust to me as well. Understand this concept. Yeah, what is it actually? For consciousness and the physical body. What he and his colleagues have found out that our gut is actually its own nervous system. Yeah, I do know about this thing, gut having a nervous system. So I do know our gut has its own nervous system. You say I have a gut feeling about such and such, you are not speaking metaphorically, you are speaking literally. Okay, got it. Yeah, it's not a personal thing. I mean, every human being experiences this. And you are not an alien, right? Every human has a gut, and every human has a nervous system and their guts. Yeah, I mean, I might have also. I think I might have also had this kind of experiences, but usually I don't. When I have to make a decision, I don't really listen to this kind of cues. Maybe I do. I don't know. I don't think you made a good decision anyway. You definitely didn't make a good decision. You could have gotten that job, you know. What bad could have happened? That was definitely not a good decision. And if nothing else, you would have gotten the experience of the interview. At least you would have, you know, got to know that. I don't know, man. Skipping an interview for a job? How is that not a bad decision? Ask yourself. Maybe it doesn't matter. I mean, it's gone, so no good in arguing about that. Calm down, man. Yeah, it may be a good decision for you. I'm just stating my view. Right, you're right. Yeah, yeah. Just leave it. So, what you are working on this week? Any new projects? Or did you start learning C++? Not that? Yeah, so what are you working on then? Math. Oh, do you want to get into machine learning stuff? Is that why you are learning maths? Or just for the exploration? Which mathematics are you learning? Calculus, algebra, or what? What? Yeah. Exploration. Oh, great. So, what are you learning then? Which part of mathematics? Statistics or algebraic reasoning? Reasoning. Are you doing that course on what is it called? Brilliant.org? I think it is. And where are you learning from? From Khan Academy or from a random, YouTube tutorial? Yeah. Books. Oh, nice. What exactly is algebraic reasoning? And the length of a piece of cloth is 8 meters, measuring cut 7 meters. Ah, nice. I mean, these problems are, very much related to the programming questions that appear. I mean, the advanced one. You do have to use the algebraic reasoning for those programming questions as well. Yeah, right. understand the words and doing the math. Yeah, right. How to, convert the words in terms of formula. I mean, the discrete mathematics part is very much related to algebraic reasoning. You got an apple, I got an apple. Yeah. What's the formula in ratio? Ratio of what? Yeah, it is definitely helpful in programming and game day. Yeah, in game day, you have to, if you are doing the, if you are developing the engine, you're going to need mathematics and physics for that. Yeah, I mean, everyone should a programmer brain works in that way. Logical way, reasoning is the only way. Not the only way, but it's the usual way. Yeah. Yeah, wait, if you want to learn more about, how a computer works, I found this book is nice. Yeah, I will drop by on your stream as well. By the way, do read this book. It's a nice one. Sure, but not this one. Code. Yeah, Code the Hidden Language. It's a good read if you want to learn how a computer works in a very intuitive way. I read it whole. It's a good book. So if you want to check it out, do check it out. Here you go. Yeah, and it's not that much long. It says it's 522, 552, but it's not that much long. You can complete it within a week, or maybe less than a week. It's a good read. Yeah. Alright, then I will see you. I'll drop by on your stream if I get up early. Yeah, right. So I should write lf of token equal to star. Then we should call self dot vmw dot write call net dot, is it multiply? Yeah, let me check the API. That was multiply integer x integer y. And if the token is divide, then we call math dot divide. Okay, nice. Let's try to test it. What's nice. Push 1, constant 1, push 2, push 3, call multiply with 2. So it will multiply this 2 and return the results. 1 and this the result of this, add and call out print in 1. Nice. We are getting the correct output. Alright, then I'm going to take a break now for lunch and I'll continue coding after lunch. So we'll be right back after lunch. Alright, I'm back. So let's continue. So let's review what we have done up till now. Okay, in the object construction, we have taken care of the caller side. Right. Yeah, now I think we also took care of the new object construction in the caller side. What will happen in this case? Wait, did we modify let? Yeah, I think we did. Yeah, I think this will work. Let's continue. So now we need to move to the callee side, and it will be a bit complicated, but not that much, I hope. So constructor new. What should happen in this case? The constructor must create a new object. Just like any method, the constructor must be able to manipulate the fields of the current object. In case of constructor, the current object is the newly constructed object. My internet download speed is very much low right now, but I'm glad the upload speed is intact. So I think we won't have problem in streaming, but still I'm not able to play back my video. Doesn't matter. Let's just hope that I can see the chat. Yeah, so let's focus on the callee. Okay, so where do we have to write the constructor code? Let's see. I need to check the grammar. Class variable declaration. Yeah, it will be probably in the not in the class variable, in the subroutine declaration. Let's go into compile. Wait, before we doesn't matter. Let's do compile subroutine. expression, yeah, this one. Okay, the logic for the object construction will probably will be written in this method. It only when the subroutine is of type constructor. Okay, let's see what should be the code. First, we need to calculate this size of an object, and size of an object depends upon the number of field variables. So here we have two variables, so we'll push 2. How can we access the field variables? Yeah, field variables will be in the compile class method. All right, so we'll probably need a variable. We'll call it number of field variables. It will be 0 initially, and we'll count a number of field variables here. How can we count it? Class name, it will be in the compile class variable declaration. So let's go there. Class variable, yeah, here. Static field Okay, let's see. Static field type variable name, if it is comma, we have a second variable name. Right, so this is what we should do. After variable name, we should increment self dot number of field weight, but we should only increase if the kind of token equal to field. Number of field variable plus equal to 1. We'll do the same thing. Yeah. This will give us the total number of field variables. Right. Now we can use number of field variables in the subroutine. push argument 0, push pop this. It's the parameter list. Okay, it's just here. So what happens in the parameter list? Let's check. Parameter list has variable name, variable name. Yeah, right. Need to push this parameter list variables on the symbol table first. My mic, I'm just using this earphone mic. I'm planning on buying a mic though. What about you? What are you using? That's why the voice is super bad. Yeah, I mean, I was also conscious of even, and on top of that, I'm using a very shitty mic. You know, earphone mics doesn't sound very good. So there you go. Even my sound is not that much, podcasty. Still, I wanted to get out of comfort zone, chirpy and bubbly. And even my sound is like that. It's not that good. It's not podcasty material. But it doesn't matter. You will get used to it. So even when I started recording myself, even I have tried to create a YouTube channel since forever, but I couldn't press the record button because I was also conscious of my sound. But this time I said, just let's fucking do it. It doesn't matter. Here I am, and you will get used to it after you do it for some time. Desktop setup. What do you mean? You mean my streaming setup? So see, right now I have a Lenovo IdeaPad laptop. This is my main machine, and I have hooked up a secondary monitor to my laptop, and I'm streaming my room and desktop setup. Yeah, so the main machine is laptop, which is the only machine. Yeah, I do have a desktop, but it's very old. It's, I think, Core 2 Duo, Pentium Core 2 Duo or something. I don't use it anymore, so I'm using the monitor from that desktop as a secondary monitor for laptop. And I'm using my smartphone for the camera. I don't have a camera, so there you go. And I'm using the earphones for the mic and for the speakers, you can see. And that is it. I don't have any fancy equipments. Yeah, I can, but I really like laptops. I mean, even though I don't get out that much, I'm not mobile, but I like to have the flexibility of taking my laptop anywhere if I want. That's why I'm not into building a desktop. And it's a very old model, so if I want to upgrade it, even though I want to upgrade it, I can't, because I would have to take out the motherboard as well. Probably the cabinet won't work as well, because it is a very old model Pentium one. And nowadays, if you want to create a custom rearranging my room. Uh, yeah. Why? For the streaming? Clean it after 4 weeks. Yeah. I mean, I don't have much things in my room, so it doesn't create that much mess. I mean, my desk is a bit of a mess. Mostly it is because of the all the wires. I have like more wires than I have devices on my desktop. I want to, slowly transition into wireless. So my keyboard is also wired, my mouse is also wired, so it's a bit of a mess. And all of the USB ports are engaged right now of my laptop. None of it is empty. For the internet also, I'm using an Ethernet cable directly to my laptop. Yeah, I mean, this is better, but wireless looks clean, less clutter. And you should try, speaking on in your streams as well, because yeah, in the starting everyone sucks. Even I suck now as well, but it doesn't matter. You will learn along. You will learn a lot. It the streaming did increase my confidence a lot. And 2 or 3 years back, I couldn't imagine myself having this kind of conversations online, live, that too live. But right now I'm out of my comfort zone and I'm learning a lot. It does helps a lot with confidence. Spectacles, I think it is 1.5. I don't know. It is 1.5, but I think it has increased. I have not checked it. In both eyes, 1.5. I got spectacles in the last, I think, 4 years only. I didn't have spectacles before. It's only when I started using laptop, for 12 to 13 hours, and I also started reading a lot. At that time I got spectacles. Before that my eyes were perfectly alright. 2020 vision. Yeah, I don't anymore. I used to go for a run before, but I don't anymore. I stopped going for a run, I think 2 or 3 months ago. Physical stuff, yeah. I mean, lately my schedule is totally fucked up. I don't so before a month I think I was regularly doing yoga, or because I started having much back pain and all of those things. That's why I started doing yoga and shit. But lately, since I don't know, maybe a month, since a month I haven't been doing physical stuff regularly. My schedule is totally messed up. What about you? Do you do any physical stuff? Parameter list. Token advance. Argument 0, argument 1. Okay, the first argument is always going to be this point, argument 0. Start subroutine. Starts a new subroutine. Scope resets the subroutine symbol table. And what? Oh yeah, alright. You load what? What do you mean? What do you love? You said you loved it. What are you talking about? Ah, sports. Yeah, I mean, you don't need friends to do workouts. I mean, for sports, yeah, but for workouts, you can do at your home as well, right? I mean, I have been doing, friends, yeah. You don't need friends to do workout and stuff. You can do it by yourself as well. I mean, it's good to go to gym and all, but it's not required. You can do everything. You can do the basic, push-ups, pull-ups at your home as well. The subroutine. Okay. What the fuck should I do here? Compile class. Okay, here we are counting the number of field variables. Meditate. Yeah, I don't do that. I mean, not in the sense, the usual sense, meditation. I mean, this word meditation it has different meanings. I mean, consistency, yeah. And the definition of meditation that I have in my mind is very much different than what it usually denotes, like sitting in a posture and trying to do different, like focus on your breath, focusing on your thoughts and so on. My definition is not mine, it is not mine, but it's a bit different. Present in a moment, yeah, right, that too, but I mean, mostly, when I do this kind of spiritual stuff, mostly it means that I'm doing some sort of inquiry into different things like pleasure, pain, and what is thought and all of those things, but not in a very intellectual sense, but in a seeing these things as it is. So that's what I really mean by meditation. Not It's not my definition, but it's yeah. And this phrase being present in a moment, it's also thrown around a lot in the spiritual sense, but I mean, most people don't get it like what it is. I mean, I don't get it fully as well. There are many consequences. I mean, we can go into this stuff, but it takes a lot of time. So that's what I call meditation, figuring out what this means actually, being present in a moment. That's what I usually mean when I say I'm meditating. Trying to figure out what it actually means, either by myself or through, other people who know about this stuff, who have gone into this stuff. So reading those kind of books and so on. Concentration. Yeah, that's what I'm saying. When most people try to do meditation, what they usually mean is doing concentration. When we try to do the usual focus on your breath, what does it mean to focus? I mean, focusing is just concentration stuff. It is not usually related to meditation. What meditation really means, it is just a concentration, like I'm concentrating right now on this code. Just the object of concentration changes. So right now the concentration is this code, and after a second it gets into the chat, and after that when we try to do this breathing meditation, so the object of the concentration is breath. But anyway, in all of this forms, the object is this object, right? So it's not really a meditation, it's more of a concentration thing. And I don't think it benefits a lot. Maybe it benefits, I don't know, but I don't think it's the real meditation. You could sense the body sensation. Yeah, right. I mean, when you do yoga as well, you can sense the body sensation. So after, when you have done all the exercises and finally when you are in the savasana position, you can sense all the body sensations. You can focus on. Still, that's the same thing, isn't it? It's focus. You're focusing on your body, focusing on different sensations that are appearing in your body. So that's also another form of concentration only, because the object in this case is your body and different sensations. Maybe, I mean, it can correlate it with meditation as well, because you can have sensations in your body and you can be in a meditative state as well. So when you come across a constructor, I have spelled it constructor. It should be constructor. When we come across a constructor type, what should we do? Wait a minute. We should start a new subroutine. Wait, what the hell is this? Null is mapped onto constant 0, true. Yeah, I need to take care of these things as well. Let's check it later. Yeah, compiling subroutines. When compiling the jet method, what? This segment to argument 0. Compiling giant constructor. The compiled VM code must allocate a memory block for the new object and set the base of this segment with a new object space address. I'm getting a bit confused here. The compiled code must return the object space address. Yeah, this is clear. files and subroutine mapping. Oh, all right. I need to write a function like this: foo.new, foo.bar. Yeah, so when we compile subroutine, when it is a constructor, do we have the name? This is the type, void or type. Yeah, subroutine name. Okay, let's store it in a subroutine name. Name equal to 1. And what we'll do here is, for calling the parameter list, let's do it here. Write the VM code function and file name dot subroutine subname. So we'll call self.vmw dot write write function. Is it called write function? Let me check. Write function. We need to pass the name and the number of local variables. Yeah, right. This is going to be difficult. Number of local variables. What's the number of local variables? Need to check the VM language. What is the function commands? Branching commands and function commands. Is it in a different slide? No, it must be here. Where is it? I don't think it is here. Yeah, it's probably in the next. Okay, it must be in the next slide. Let me check projects. 7, 8. Yeah, this one. Function. Yeah. Wait, what? This is 8. Yeah. Okay, in VM everything is a function. Subroutine, function, procedures, methods, everything is a function, right? Oh yeah, two local variables because x and y. Wait, are these two local variables or the parameters? I don't get it. Or is it 0 in this case and 2 in this case? Is it the same as this? Initialize the local variables. Wait, arguments are, yeah, right, arguments are local variables. Right. What other local variables do we have besides an argument? Are static variables? No, static variables are not local variables, of course. What about the other variables? Wait, local 0, local 1. Wait a freaking minute. Yeah, NVAS is for local variables. This arguments are different. Argument is a different thing and local variable is a different thing. Yeah, right. So what a local variable refers to in this case is the local variables which we actually have. So let's see, in this case, which we have x and y as a local variable, right? Wait, no, they are. We don't have any local variables in this case, I think. Okay, let's think about it. What kind of variables do we have? We have fill static fill static variable. Fill static class variable and argument and fill static class variable. What the hell is this class variable? Yeah, it's a category of an identifier. No, I don't make any notes. I don't usually, but yeah, when I want to, sometimes I do make notes, but they're not really what you can call notes, because I'm just noting down things. I'm not noting it for, retrieval process. I don't really learn in that way. I tried to create a note taking process when I was doing bug bounty. So I use this software. It's called Obsidian for notes, because in bug bounties you have to, when you are doing recon stuff, you have to write down the information. So I use this software Obsidian. I also try to use that one, what is it called, Notion, for note making, but I don't really like note taking. For programming, I don't take any notes. I don't really learn that way. But yeah, I do take notes of this kind. Let me show you. Like this. So it's just when I want to think about something, I take notes. So like I did with excuse me, with this thing. When I was thinking about career and stuff, I took this kind of notes. It's basically, yeah, this Linux Ubuntu. I told you about it, didn't I? Obsidian, yeah, this one, yeah. Wait, let me send you. It's a nice app, but it's quite heavy, I think. You can use, the markup language to take notes, and you can link back to different nodes. It creates like this kind of structure, mind map kind of structure. It's not exactly a mind map, but graph like structure, so you can have, links to different nodes and so on. It's a good app, good idea. Variable argument static field. Yeah, uh, you don't need to install it. Wait, you can just download the app image and you can run it. You don't need to install it. Let me show you. I think I have it in tools. Yeah, and it's not here. I need to find it. Find what? Obsidian. What the? How can I find this particular file? Oh, I can use FCF. Obsidian. Do I have an obsidian? I think it must be in my downloads directory, maybe. Let me check in a browser. Yeah, and I wrote SHL because it sounded like shell as well. Shell, this cell, like this cell. This is called a shell. It's a G shell. There's a bash shell as well. So that's why I took it as a, I wrote it as a username, shell. Not that diff. Yeah, I found it. So here it is. This is the app that I was talking about, Obsidian. So I took notes for when I tried to, learn Android hacking. So you can link to different nodes like this, Dalvik cache. And this is the graph view of all my nodes. Like this. You can filter using the different files and tags. I use this software called let me check, DroidCam. It's a software for Android as well as for, let me check, DroidCam. Using this software you can use your phone as a camera. You just have to download it in your, you had that. Did it not work for you? See, like this. So right now I'm using USB mode, so I have to connect my phone using USB, but you can use the Wi-Fi mode as well, but it has it has a larger latency than USB. USB is much better. That's why I use USB mode. And there are two different apps for Android. One is this one, DroidCam, and there's another called OBS Droid. So for some reason it didn't work for me, the OBS version, so I had to use DroidCam. And I think you can directly use it. When I tried, I had to set up some different things to make it to work. I think I had to create some configuration in the Ubuntu. It doesn't work out of the box. How to What do you mean? How to what settings? You mean settings of this? Yeah, it is. I think it is a bit complicated. Let me check if I have the tutorial or something. OBS. You mean how to configure it with OBS, the Droid Cam? Let me check if I have that article around or not. Whoops. OBS include. By the way, if you are going to use, no, it won't be a problem for you. I don't have that article around. Let me show you. Let me show you my properties. So see, it doesn't work out of the box. I mean, I'm talking about this Droid Cam. So there are two Android apps. One is Droid Cam, which is what I'm using right now, and there's other one called OBS, OBS Droid or something. So I think it works out of the box, that other one, but it didn't work for me, so I'm using Droid Cam. But for that, to use Droid Cam, you have to configure a loopback device and so on. It's quite a bit, it's complicated. You won't be able to do it right now because you need to create this loopback device, which is Droid Cam. I had to Google a lot to find this particular configuration for Droid Cam. You have to do some configuration in the terminal to create a loopback device particularly for your mobile. After that only it will detect your smartphone as a camera, or else it won't detect it by default. Let me see if they have a tutorial or not. How to connect Droid Cam with OBS in Linux. Yeah, sure, you try to do that. I mean, see, you might have to, yeah, this, I think this they have a tutorial for that, how to install. See, let me send you the link. You might mess up your drivers, so try to do it carefully, because it works with the loopback drivers. You have to do all of these steps. So see, this one is, it works out of the box, maybe this one, but I'm using this one, Droid Cam. So try to connect with this one first, and after that you try to do with this one. This website will give you all the tutorials. Class variable declarations. Okay, this variables are at the subroutine level. Damn, it's complicated. Where should I start? What to call this function? File name, subname. I need to pass number of local webs, but I can't get the number of local variables. I can get the number of local variables when where can I get using, wait, I think we have a function just for that. Is it? Right now we are at 79th slide, so let's check the API. What's the freaking API? Yeah, I'm just trying to find the API for symbol table. Yeah. You can get the variable count using, yeah, this returns the number of variables of the given kind. Right, you can use this method to get the number of variables, local variables. But before that, I need to create the symbol table of the subroutine, and I need to pass. What do I need to pass? Wait, the, yeah, this is, yeah, correct. It's correct. I need to create a symbol table for the subroutine first, and I need to define the variables. I need to define the arguments as well. Okay. So let's see what happens when we are at this point. Class name, class variable declaration, and subroutine declaration. So what happens in the class name? Are we doing anything here? Since we are not doing anything in the class, in the compile class variable declaration, yeah, it's a different thing altogether. But in the subroutine declaration, what should we do? We need to create, let's check. Compiler creates the subroutine symbol table. Yeah, right. Holy fucking hell. Oh. Compile parameter list. Yep. Oh, what should we do now? Compile subroutine declaration. Yeah, we need what we need to push the number of field variables. Yeah, right. We're counting the number of field variables. Yeah, we're counting it here somewhere. Wait. The spelling of this is incorrect. Then how is it getting called? What was incorrect all along? And how is it working? Should be PARAMMETER. Did I delete the character right in this string, or was it like this all along? If it was like this all along, how did it work? Wait. Now where am I using this? Parameter. Oh, everywhere I'm using it. Spelling is same without E. Let me check the grammar. Where do we use parameter list? In here in the subroutine declaration. That's the only place where we use parameter list, right? Yeah, right. So that's why we didn't got it. And spelling is consistent everywhere. Let me change it. Compile parameter list. I hope it is correct now. Okay, what should I do now? Yeah, so I need to push the number of field variables and compile subroutine declaration. Parameter list. Just the class declaration. Yeah, it is here, class variable declaration. And we are counting the number of field variables in the and field variable. All right. And we need to push it onto the stack. That's cool, but before I push it, I need to create a symbol table. And yeah, I need to create a symbol table, and I need to pass AX and AY. Do I not need this? Well, I think in case of constructors, we don't pass this pointer. But in case of methods, we will have this, right? Key one will be this. In this case, in case we are compiling methods, we need to push this. Oh. Okay, let's figure out where we should start creating the symbol table. Subroutine declaration. What do we mean by creating a symbol table? Just starting the subroutine and defining, pushing the arguments and the local variables, right? So the arguments are inside the parameter list. Right. And the local variables are in the subroutine. Okay, let's check the parameter list first. Okay, we can do one thing. Let's check VM writer. We need to call not this VM writer, not VM writer, symbol table. We can call start subroutine. Okay, we can call start subroutine inside the subroutine declaration. So start subroutine symbol table. Self dot symbol table. What's the variable name for symbol table? It is st. Okay. Start subroutine. Okay, this will clear out the symbol table. Okay, now we need to push this point only when it is a method. We need to push this only when it is a method. Check the symbol table. The name will be this. Type will be the class type. Kind will be argument. Six. Right. Parameter list again. Parameter list. Yeah, right. So what we can do here in subroutine declaration, we need to check if, let's see, append this in the symbol table if subroutine is a constructor, right? So how are we going to do that? Self dot st dot, we can call define define name, t type, and kind. Name will be this. Type will be t type token. And kind will be arc. But we need to do this only if let me save it in subtype. Sub r type equal to if sub r type equal to constructor, then only we define it, this thing, this type token and r will work. And now we can move to parameter list here as well. What we'll do, we need to append all these variables in the symbol table. So how can we do it? If token is equal to not this kind of token, this is the type. The type is in type token. Wait a minute, we're already defining it. Yeah, right. We have already taken care of it. We are passing the name of the token, which is where it is here, and type of the token, and the kind of the token. Do we get the kind of the token? Are we getting it? Yeah, it is here. It's arc. Oh, nice. We've already taken care of it. What's this part? Yeah, what's that? Okay, this is good. And so now we have taken it. Yeah, we did take care of the symbol table creation. Now what do we need to do? Yeah, right. We haven't taken care of all the variables. So these are all the parameter list variables, which are the argument variables. But we need to take care of the this variables as well. We need to add them. Subroutine level declaration. Subroutine declaration. It should be inside the subroutine body. Let's say if it is a variable declaration, if it is, then we call compile variable declaration. Compile variable declaration. Do we have a separate method for that? Oh, what? Compile variable declaration. No, not this one. Text. Yeah, it is here. Where else are we using the variable compile variable declaration? It's here, variable declaration. It is inside subroutine body. Where else are we using the variable declaration? It's just here. Yeah. Right. But what are we defining it as? We have the variable. What is this? Kind of the variable. It is a var type and name. So we call define name type and kind. What's the kind in safe? Are we getting kind? Yeah, this is incorrect, I think. Kind is variable, but it should be local, right? Let me check. Yeah, this is incorrect. This is messed up because we are passing the upper form, capital var. So this, does this work? We are storing the kind as capital, this capital value. It seems to be working, it seems. Should we keep it as it is? Yeah, using the kind token here. So instead of var, we should store it as a local, not var. Shit. This should be local. Okay, what the fuck? We'll just store it as a capital form. It doesn't matter. Where else did we have var? Yeah. Nice. Now let's go back to compile the declaration, and in this case and instead of var we should be having, let's see, we should have local. Okay, good. Now inside the symbol table right now what? These indexes are incorrect. We have only taken two indexes, class level and a symbol level, but these are not class level or symbol level indexes. These are a kind level. So for fields it starts from 0 1. For static, yeah, I need to change it. What's this count? Yeah, it's a variable count. So let's take this in self dot, we need a field f index yeah, f index, s index for static, a index for argument, and l index for local. All right. And when we call start subroutine, it should set the argument index and local index 0, and inside define, yeah, right, wait up. So now we need to Assign the index based on the kind. Right. Okay, that means I need to pass it as different arguments, different, not arguments, but different conditions. In this case, we will only check if kind equal to static or not. If it is static, yeah, right. S index. Okay, nice. In this case, kind equal to let's see, filled f index here as well, f index lf kind equal to arc. Wait, are we going to have arc or argument? I need to check. It is saved as arc, right? Okay, it freaking doesn't matter. Let's save it as arc then. This should be a index, and this as well. Kind equal to, what's the final one? Local. Right, so this is correct now, and we don't need these two variables. See, let's see if we need to do anything else. Variable count, no, kind of, no, type of, index of will be correct as well. Okay, so it seems we have taken care of the creation of the symbol table. What do we need to do now? Holy shit, what did I do? Now let's go back to compilation engine, and where were we? Constructor sub type is constructor, we call this type token is argument. Yeah, right. After that we go inside parameter list. We are already passing the parameter list inside the symbol table. Name token, type token, kind token will be arg in this case. Hey, it's Coder Life. Thanks for the follow. How are you? Kind token is equal to argument. Yeah, right. And finally we'll have local variables. It will be site compile variable declaration. Yeah, right. The kind will be local, and we are already defining it. Right, so we have taken care of the symbol table creation. Now it becomes easy. What do we need to do now? This is the compiling method part. Let's go back to constructor compiling. Compiling methods, compiling the constructor. Yeah, let's see. And do we have access to the local variables now? The count of local variables. When are we going to have, see what does this number denotes? Denotes that what is it? We have two filled variables, right? Yeah, right. Let's go back to compile subroutine declaration. Yeah, comment this and write a to do. Ooh, what's the do function file? Yeah, we'll take care of it later on, but right now need to write the code for constructor. We need to push the number of field variables onto the stack. After that we'll call memory alloc and one argument, which is this one, pop pointer 0. This will set this at the base address. Yeah, right. And after that, what do we have? Let x. It's just this thing. Should we do it in the subroutine body, or no? We can do it here as well. So if the subtype subroutine type is constructor, along with defining this argument, what we'll do is we will call self dot vmw dot write call, and the function name will be memory dot allocation alloc, and number of arguments. Wait, no. This one, before we call this, we need to write self.pmw dot write. Yeah, this is all of this is part of this course that I'm doing, Nand2Tetris. So all of this documentation is from this course, and right now I'm writing a compiler for this, a made-up language called Jack, which is somewhat similar to Java but not exactly. So the code looks like this for this language Jack. So I'm writing a compiler right now, and in this course what we do basically is try to create the whole computer from scratch, from the NAND gate up to the operating system. So right now I'm at this stage in the project 11, writing the compiler, and after that I'm going to write the operating system. And all of this is part of this course on Coursera. So it's provided in 2 parts. First part is this one in Python. I'm not using C++, just Python. So this is the first part, and it contains I think up to the assembler. And from project 7, it's from project 7 onwards, it will be part of second course, which is this one, which I'm currently doing, and I think I've almost finished. And final project will be operating system after the compile. Where is it? Let me show you. Yeah, it's the syllabus. And it's not a big operating system containing all the syscall modules and all of those things. It's just just library, like it was in earlier days of the computing. It doesn't contain much things, so it only contains library functions like let me show you. Yeah, sure, wait. So this is the part 1, and this is part 2 of the course. And there's also a book which you can follow along. If you don't want to do this course, you can follow along with the book as well. It is called, I think, Systems. Forgot the name. It must be here somewhere. Book, yeah, this one, The Elements of Computing System. But I prefer the course because I learn in a very visual way, that's why. And you can just pace through the course. So what I usually do is put it in a 2x speed and walk through all the videos in a one module, and after that I just open up the slides. So these slides are part of the videos only, so I just 2x through all the videos, and afterwards when I'm into the implementation stage, I read the slides once again, and I try to implement the stuff. And this course is good because it is unique in the sense that it doesn't walk you through each and every step. Like, it doesn't give you each and every code line. You have to figure it out by yourself. So it doesn't tell you that you have to make the compiler in Python only. You can create it in your own choice of language. So I'm just using Python because, yeah, compiler, but not a fancy compiler. It just contains bare bone things. Certification. No, I'm just doing the audit part. I'm not doing the certification. I don't really care about the certification. I just want to learn how a computer works from scratch. And let me show you what does it look like. So it doesn't, you don't have to create this hardware components. You can use the simulator to simulate all of these gates. So first you start with these gates. You are only given the NAND gate, and from that NAND gate you have to create NOT, AND, OR, XOR, and so on. And you don't have to create the physical parts. You can use the simulator provided with this course, and you are going to use a language called hardware description language to design these components. After you are done with these basic chips, mux and all of those chips, after that you will create adders, full adder, half adder, and 16-bit adder, incrementer, and an ALU unit. And what's the third thing? After that you will create sequential logic chips like RAM. This is a data flip, so you are already given data flip block, and from that you have to build up 1-bit register, 16-bit register, and so on. So it's pretty cool. I mean, you get to know how this component works, how a computer works from the ground up. Now you can read a book about how a computer works, but it won't give you the the concrete knowledge. When you try to build it like this, you will get the knowledge in a very granular layer. But this course doesn't go into all the finer details of the modern computers, but it provides just only the essential part. So in that way it becomes easy to create a computer from ground up, but you learn a lot this way. So before starting this course, I read this book, Code. I looked for it in this morning only. Not this one, Code, the Hidden Language. Yeah, this one. This book is nice. It gives you an intuitive sense of how a computer works, but even though I read the whole book, I was not getting it, like how it actually works. So that's why I started doing this course. Yeah, right. What was I? Yeah, I need to write this push too. Right, push. Nice stuff. Yeah, it is nice. You're welcome. Right, push. What do I need to pass to this function? Yeah, a segment. I need to pass a segment and index. So in this case, the segment is going to be constant and index will be the number of field variables. Right? And after that we'll call memory alloc and one argument, so 1. So this will cover the part where we have to create the constructor. After that, pop pointer 0. Yeah, right. Self dot emw dot write pop. The segment is pointer in this case, and index is 0, right? And this thing we have already taken care of it. Oh, we need a return statement as well. But we have a separate method for return. I need to check subroutine body. Yeah, we do have a separate method, compile return. Okay, what should we do in this case? Push pointer 0 and return. Wait, what? Return this. All right. When we call the compile expression, it will push the expression, the value of the expression itself. So you don't need to push anything, just have to call the returns the base address. So wait, but what if we don't have a return value? So in case of constructor, we're definitely going to have a return value in form of this, the base address of the newly created object. But when we are compiling the method calls, that besides that we do have to take care of other things as well, but let's just see. Yeah, right. Void methods. Yeah, what happens in case of void methods? We need to push constant 0 in case we have a void method. Yeah, right. We can take care of it later, but first let's write VM code dot self dot w dot write return. I don't think we have to pass any arguments to return. Let me check. Yeah, it doesn't have any arguments. Let's just call return. But before that, before we call return, write return, we need to push. So in case we do have an expression, what do I need to do now? Let me go back to subroutine body. Where is it? Let statement, compile statements, subroutine body. Yeah, I'm calling the Wait, we're not calling the return statement. According to the grammar, return statement, yeah, but return statement should appear in the subroutine body. Oh, wait, it seems we are not even calling the return statement anywhere. Right. So now what should we do? We need to check if we have a return statement or not. Compile return. Yeah, we are calling it here. Let if while do return. Alright, so return statement is part of the statements. So we are calling it from here. Subroutine body return statement. But what if we don't have a return statement? What? Statements are part of a subroutine body as well as where else does statement appear? Inside this part. Compile statements. So let's think it out from the topmost position. See, we can have two types of methods or subroutines. One type is constructor, another types, function and method is just other type of method. So in constructor, we are definitely going to have return value, right? It will be this. So we are going to have a return statement in case of a constructor. That means on top of the stack we'll have the return value of this. Wait, did we take care of it? The return value? This is method. This is the constructor code. Yeah, push pointer 0, which is this. Are we pushing it somewhere? So after we are done with the statements of the constructor, we have to push pointer 0. Are we doing that? I think we are not doing it anywhere. Some routine declaration if the sub R type is constructor, we do these things, and after these things call parameter list and compile subroutine body. Yeah, right. After we done with the subroutine body. Compile parameter list subroutine body variable compile variable declaration. This will take care of all the variable declaration, and after that we will do compile statements until we hit and a closing bracket. Yeah, right. So we need to have a way to know if we have if we came across a return statement or not, right? See what should happen. We are not worrying about the statements, but in case of constructor, we'll have the last statement will be the return statement, and it will call compile return statement with the token. That's the return statement. Compile return statement. Yeah, right. It's we call write return, but before we call write return, we need to push the pointer 0 value, which is this value of this, so that we have access to this value when we return. Can I do this? But I should do this only when this return is inside the constructor, not elsewhere. I mean, we are calling this method from other kinds of methods as well, like method calls and the function calls. Okay, what if I pass what's unique in case of constructor construction? Wait. In case we have a constructor in the symbol table, we will have we won't have this already, right? So we can check the symbol table if we already have this or not, this value. Yeah, this is much better. Let me check type of kind of variable count. Return call kind of name. See, in case of methods in the symbol table, where is it? We will have this value, this, but in constructors we won't have it, so we can do something like this. self dot symbol table dot kind of, and we are going to pass this, and it will return. We will check if it returns the kind or not. Let's check if it doesn't exist, what does it return? Kind of. Where is kind of? Kind of variable count, kind of. Yeah. So if the value doesn't exist inside the dictionary, it will return none. Right. So this is better. We can check it like this. If it exists, no, we need to check if it doesn't exist. So not. If it doesn't exist, then we can self dot vmw dot write push. What do we need to push in this case? Yeah, we need to push pointer 0. Segment, pointer segment, and index is 0. Nice. Great. This will take care. Oh, what happened? What's this? Okay. Now let's see what do I need to do. I'm pushing the pointer 0 value on top of the stack and calling return. So it takes care of the constructor code. Okay, now I need to take care of the method calls. So let's see. For the method calls, we have taken care of the caller part. So now for the callee part, this is the method. Symbol table for the class level. We have created the symbol table. Yeah, this is the compile code. Push argument 0, pop pointer 0. Yes, let's see if this happens or not. We need to go to compile subroutine. Declaration. All right. If the subroutine type is constructor, we do these steps. But if it is not constructor, what should we do? Push argument 0. Right, are we already doing this pushing of arguments? This is argument 0. It is this pointer, right? And pop pointer 0. It sets this to argument 0. Okay, and push this 0. Wait, what? Yeah, it's for this thing. Okay, so we have already taken care of all this code. We just need to do these 2 steps. The compiler constructor method symbol table new code is generated. Next, it generates the code that associates this memory segment with the object on which the method was called to operate. Yeah, right. So let's do that. else self dot vmw dot write push argument 0. You know what? We should have done this in the subroutine body code. We are inside the subroutine declaration right now. Does it make any difference if I move this code to subroutine body? And does it make it any difference if I keep it here only? Nah, I don't think it makes any difference. Then just let's just call like this. Right push, the memory segment is argument, and the index is 0. After that, self vmw right pop, the segment is pointer in this case, and index is 0. Nice. All right, nice. This is good. This looks correct. Yeah, this is correct. Now what about this to do? Yeah, it doesn't matter. I need to write the return statement, so we should go back to compile return. Yeah, right, so this doesn't exist. Okay, push pointer 0, but if this exists, then what do we push? Do we even need to push anything? Yeah, I mean, if the method, see, if the method is void, we need to push constant 0, right? Or else we can just call return, because we can't just leave it as it is. We need to return something. In case of void methods, we need to push constant 0. Yeah, so it doesn't matter. So what we'll do, where's the subroutine? It is in the subroutine. Subroutine declaration. Yeah, this, so subroutine declaration knows if the type is void or not. Yeah, if the type is void, the subroutine type is function or method and the type is void, then we need to push constant 0. but when should we push it? At after we are done with the subroutine body. Wait, no. Subroutine body will call the return statement. We need to check it in the return statement as we need to check it in the return statement itself. How are we going to do that? Yeah, right. So see, you can check it like this. If the first token is returned and if the second token is this one, semicolon, that means we don't have a return value. That means it is a void, right? Yeah, so let me create a new variable called void type. It is false by default, or maybe it is true. If the token not equal to this, then we'll change void type equal to true. Why? Because if the next token is not a semicolon, that means we know there is an expression after the return type. That means it has a return value. Oh wait, it should be the other way around. This should be true by default, and we should change this to false. Void type is false. Now we can do something like this. Not elif void type, not void type. So if this is present, that means it is a method or a function. Wait. But if it is a function, we won't have this, right? Or are we going to have this in case we have a method? Not method, a function. So what's the difference between a method and a function? A method is a part of an object which can access the elements. Let me phrase it correctly. So a method depends on the object, but a static function is kind of a static, so it doesn't depend on the object. It works on the class level, like this get point count. It doesn't depend on the object and the object variables, right? So if it doesn't depend on the object variable, it probably won't have this keyword value, right? I need to figure it out. If that's not the case, that means we need to change our code. Push constant 0 return. What the fuck is it? Wait, there was something at the end. So let's check it out. 67. Yeah, it was somewhere around here. Where was it? Yeah, it's a voice classes subroutine calls. The subroutine, compiling a subroutine call. Caller must push the arguments and the subroutine is a method. The caller must first push a reference to the object on which the method is supposed to operate. Next, the caller must push argument on to and then call the method. Yeah, okay. And if subroutine is void, a jack subroutine is not required to return a value. Functions are required to always return a value. Damn, this is another thing I need to take into account. This is quite complicated. Let's just assume that this is present in the function as well. So what should we do? Where's the code? Where's the code? Directs. Yeah, this one. Push constant 0. Stuff.vmw.write push segment will be constant and value will be 0. Okay, this seems correct, but in case the method is void, I need to dump that value as well after in the caller code after call point. So when are we calling the methods? I need to check grammar. Subroutine call. So subroutine call appears in the term, expression, in the do statement and in the expressions, right? Let me check. Write call. What method is this? Compile do statement. Yeah, right. Here I need to check where did it, where is it, yeah, it's here. So yeah, in this case definitely we don't need the return value, so we'll call vmw dot write pop page up. Where should we pop the value? In the temp section. temp 0. Right. Where else do I need to write this pop? Just here only, because in other cases wherever the subroutine call appears, it appears inside the expression. So in the if it appears in the expression, that means we do require the return value, right? Yeah, correct. That means we don't need to change anything else. This is correct implementation, and with that I think we are done with the method calls mostly. And do we have a test project to check if our compiler is working or not? Check conversion to bind. Test how your compiler handles all the procedural elements, expression functions, and all language statements. Yeah, we can test it on this. So let's try to do that. Yeah, I need to compile. Let's compile main.check again. Okay, so this is the output which we are getting. What happens here is, in this case, we push argument 0. Wait, what's the argument 0? This is setting this. Alright, so here's the thing. When we have a function and not a method, the argument 0 refers to, it doesn't refer to this pointer. So this is probably, this is incorrect. We don't need to do this thing. So I need to change the code. Should I change it? What's the code again? Argument 0. Yeah, it's here. Yeah, it's simple to change this. Let's change it to sub r. Oops, sub r type equal to method. Then only we'll do this thing. Okay, let's compile the program again. Great, we are not getting it now. What happens? We push 1, push 2, push 3, call multiply with 2 arguments, and we'll get the output on the top of the stack. We call add, it will add 1 and the return value of this, and after that we call this, call out println. It will print the value of this expression, and it returns a constant value on top of the stack. So we pop it into the top temp 0. After that we push pointer 0. Why don't we push pointer 0 in this case? It's a freaking method function, not a method. So should we push pointer 0? We don't even have a pointer 0 value in this case. It's a freaking method, function, not method. They have not even provided enough examples. Why do we even have this push pointer value? It's not like this is a constructor. I see why. What's happening here is we check if this exists inside the symbol table or not. It should return none. Yeah, right. Because it is a function, this doesn't exist, right? Wait a freaking minute. I'm gonna go to the bathroom. I'll be back in a minute. All right, let's continue. So I was looking for this. Wait a minute. Why are we pushing this? All right, push this index token. This should be, yeah, this is correct. If the type of subroutine is a constructor, then we define this. We don't even have a constructor in this case. Right? It's just a function. Then why are we getting this push pointer 0? It should not be printed push pointer 0. So what happens when we call self.st kind of this? Oh wait, fucking. Oh yeah, it's the kind of name. I see. Let's see. Doesn't make any sense. Right, push this index token. Check the symbol table 58. Yeah. So the kind of field variables, yeah, it's just field. Don't get it. So self.st kind of this, we pass this and it should return, yeah, let me try to log it and see what it is actually printing. Print this. Let's see what we get as the value. This. Let's check the log now. Whoa, what? Ah, of course. Yeah, so this means that we are getting none as the type, right? So we don't need to change it. We're getting none. If we not none, it should be true. Yeah, of course, I get it now. So when we don't have this, what does it mean? It means we don't have the constructor. It's not a constructor, right? It's a method, and when it is a method, Freaking hell. No. It should be other way around, right? Let me see. I'm getting confused here. When we are compiling constructor, what is it? In case we are compiling constructor, we should push pointer 0. So it should return none when it is a constructor. But for method also it will return not, right? Because inside in method we are not pushing pointer 0. Yeah, right. Yeah, this is correct. Holy shit. Oh, this is confusing. Fuck. What should I do now? What should I do? I'm getting confused because the documentation is not clear enough. It doesn't tell you what happens when we have a function. It should be push. This will not work probably. I need to change this. It should be the condition now. How do I check if the current subroutine is a constructor? Compiling methods, compiling method calls. To enable this, the method's code must anchor this segment on the object data using pointer. subroutine, subroutine body, subroutine declaration. Yeah, right. So here we have access to the subroutine type, constructor, function, method. Right. After that, we call subroutine body. Now inside subroutine body, we don't have access to the type. What if we pass the type of the method to subroutine body? Will it make any difference? No, then we'll have to pass it to compile statements as well. Yeah. And compile statements that contains return, and it calls compile return statement. Yeah. Okay, what if we push this variable when we are compiling functions as well? Does it make any difference? But this will be incorrect because argument 0 will be something different in this case. So we have a conflict between two types, constructor and a function. Let me lay it out. See, we have three types of subroutines. One is constructor, second method, third one is function, right? So now we have return statements in all of three of them, and in case of constructor, it is going to return pointer 0, value of pointer 0, or this value, right? That's what the constructor should return. So it does have a return value, right? Second is method. Now method may or may not have a return value. So if it has a return value, we should return the expression. If it doesn't have a return value, we should return constant 0. Same goes for the function. Okay, so what's the issue then? The issue is I need a way to check if the current subroutine is a constructor or a method or a function. If it is a constructor, I need to write this pointer push pointer 0. If it is not, then I need to write, if it is not a constructor and if it is a return type is void, then I need to write constants. So now the issue is, right now I'm checking if this exists in the symbol table or not, but this exists. It doesn't exist in case of constructor and function. So it will write this pointer 0 for the function as well, which we don't want to. So how to distinguish between constructor and method and a function? That's the issue. It's the nub of the issue. Wait a minute. I think I know how to solve this issue. Let's go into variable symbol table. So what we can do is we can have a variable called current subroutine type, and it will be, I don't know, by default it will be nothing. And when we call the start subroutine, we will pass the subroutine type. Great. So now what we can do is self dot current subroutine type is equal to sub r wait. Subroutine type, current subroutine type is equal to subroutine type, right? So let's now go to, we are calling the start subroutine. So now we are going to pass the type, and which we already have. We'll move this code from here. Great. And we'll pass sub r type here. So now we have access to the subroutine type. Now in the compile return, what we can do, great, it makes our problem very much easier. Now what we can do here is we can just call self, oops, I need to write a different function. Let me write a function called define is equal to so type of, not type of, sub get sub r type, get sub r type. It will return self dot current sub r type. So what we can do here is just call self dot st symbol table get sub our type. If it is constructor, and we'll push this. And if it is not constructor and the return type is void, then we'll push constant 0. Great. Let's check the output now. Yeah, this is correct. Call this is and we call pop time 0. Okay, it seems we're getting the correct answer, and let's now try to compile a different project. This time let's try conversion to binary. Convert to bin. Yeah, convert to bin. Nice. Let's open it up. Convert to bin main out VM. Ooh, what the hell is this? Main.fill.memory. What? I need to check the check file now. Convert to bin plus main.check. Yeah, right. So let's see what happens. We push 8001, then push 16, then 1 and negation, and we call main.fill memory with 3 arguments. Great. After that we pop temp 0 because we don't need the return value. Great. After that we push constant 8000, we call memory.pick 1 argument, and we pop the return value in local 0, which is the value variable, right? I hope so. And after that we call main.convert 1. Wait, is this correct? Yeah, I mean on the top of the stack we have value, right? The value of value, this value. This is correct. Nice. And after we call pop temp 0, we dump the value. After that, wait up, what is this now? Yeah, we get the return. Why don't we have a new line variable? Check v5 return. I think I forgot the new line character. Yeah, I didn't I? Forgot a new line character, so I need to recompile it. Oops, not this. Yeah, now this is correct. So let's see. We have a second function, and yeah, we still need to write the function VM4, but we'll take care of it later on. Let's now focus on this thing. Why do we have let loop is equal to true? Don't have it. I know why. I just have main while we don't have this thing. Let loop is equal to true. Let's take care of it. Let loop is equal to true. Compile. Let's statement. I don't know why this is happening. So what the let statement say? We call expression, right? Yeah, compile expression. So let's go into the compile expression method. The list expression, yeah. Yeah, let's say compile term. What if the term is not an identifier? What happens? We don't do anything? Oh, what the hell? Let me check the grammar. The term is a keyword constant. What happens in this case? Yeah, I'm not even checking it. So I should probably check it here. Token is keyword constant. So elif, wait, what? Why would you do that? Self dot pkz. Wait. Tokenizer. Do we have true in the keywords? Where's the keyword? Yeah, it is inside the keywords. But we probably don't need to check for all the keywords. We just need true, false, null. I mean, yeah, we won't have all of these keywords. We'll just have true, false, null, and this. So we can safely call. Token type, because we know the tokens will be either true. Wait, it can be a class, isn't it? Token can be a class. No, it won't be. So keyword. Why does it get indented by itself? Yeah, so in this case, what should we do? Self dot bmw dot write push. Yeah, I know what we should do. It was somewhere around here. It was mentioned somewhere around. Damn, not again. To reload it again. Oh yeah, we still have to take care of all of these small things. Object recycling and so on. Yeah, but if true, false, true is mapped to -1, false to 0, and null to 0. True, false, null, and this. Okay, how about this? So what if this is part of the expression? Hmm? Can this be part of an expression? Yeah, it doesn't matter. So now I need to check if token equal to true. In this case, where should I push it? Yeah, as a constant. So for this, for true we have -1, for false 0, null 0. Wait, for null as well 0. Okay, so -1. And if token is, oops, false, not false, false. It should be 0. For wait, it is false or null, it should be 0 in either case. And the final case, or the else case, we'll just push constant. Wait, no, we can't push constant. So the, if it is not true, false, null, it will be this. So yeah, we need the index token, right? But this is not an identifier, right? Or is it? Let me check. What does it mean by an identifier? Symbol, yeah. Keywords, is this in the keyword? Yeah, this is part of the keyword. This THIS, this is part of the keywords. That means it won't be under the identifier. So we still need the index token. Wait, why would he have this in Jack language? What's the use of this? I don't get it. This is not mentioned anywhere. Syntax conventions. Jack OS API. No, I don't need this. I don't think we have a use case for this. Does this appear anywhere? How can this be part of a keyboard? I suppose even if we have this as a keyword, what do we do? Something. Hmm. Wait. You know what? You can do one thing. You can look through all of this jack files. Get star dot jack will pass the output to grep when grep for this keyword. And up with that, nothing at all. Yeah, I know why. Get the recursive. Do we have a recursive? Nand cat. Do we have a recursive ls all? Yeah, recursive. No, it doesn't work. Capital R. Okay, this is nice. Yeah, but how about this? No. I think I can pass all the files directly to grep. Do we have a recursive grep first? Grep for speed. Let me just Google it. Grep for a specific word in multiple files in a directory. Okay. All right, let's use grep like this. Grep r and what was I looking for? Damn, I forgot why I was looking for it. Yeah, this keyword. This. And not all files, but dot check files only. Huh? It doesn't work. Oh, wait, good. Return this, memory alloc this. So let's open up this square game. Square game dot check. Oh, yeah, we are using this. Does this refer to here? This object itself, right? But what now? We do have this, but what should we do with it? If it is part of an expression, what should we do? This refers to argument 0, right? Right. This refers to the base address of the current object. Yeah, of course, we can access this when we are inside method. It will be inside in the argument 0. Wait, so yeah, right. So this should be argument 0. Right. Now what Let's try to recompile. Compare it now. Where is it? Let loop is equal to true. Yeah, it is here. Push constant -1. Wait. Why is it not popping it into loop? This is not correct. It should pop the value in the loop. Are we not popping it? Let me check. Compile. Let. Here's the let. Is the variable name. Yeah, we are not probably popping it. Why do I remember that I did it? I feel like I wrote the code for let. Yeah, I mean, for this it worked, right? Why did it work for this case? Let's see, memory dot pick 1 push local 0. So it worked for this thing value. Why did it not work for the other? So it didn't work for this let loop equal to true. Why? How can it work for one and not the other? Let me find right pop. Wait. Of course, it didn't work for this as well. Why did I think? Then what is this? Push local 0. Yeah, just this one value. Just pushing the value. Yeah, so it is not working because we haven't even written the code for this part. But it will be a bit trickier. Why? Because what's the grammar? Yeah, let variable name an expression. So we can't directly pop it into the expression into the variable name, because we need to handle the case where we have an array. We'll handle it later. Let's first handle the case where we don't have an array. It's just a simple variable. In that case, what should happen? Yeah, so let's write an else block here so that we can take care of array later on. What we can do here, self dot vmw dot, is this the right place? Yeah, I think this is the right place. I can do right pop where now. Okay, I need to grab this variable name, where this variable name is, to know where it is. I need to use the name to get the segment where it exists. I can use the symbol table for that, right? Segment equal to self dot st dot, let me check the symbol table. What's the API of symbol table? Yeah, this one. Let's see, what should I call? I need the segment name. I mean, this variable can either be, let me check again, in this variable name. This is an identifier. What is an identifier? It will be either a static, a field, argument, or variable, right? It can't be any other type, any other kind, right? So we need the kind, not a type, but the kind, right? So we'll call kind of, and we are going to pass the name token. I don't need this code. This will give us the kind. Let's see now. We have got the segment, and we need the index as well. So get the index. Index is equal to self dot st dot index of name token. This will give us the index. Now we need to check if segment equal to static. In this case, here the segment will be static, and we pass the index. and now it is filled. What? What the fuck? Oh, why is it messed up? Holy freaking shit, I messed up the whole code. Ah, not again. Why can't I go back? Why can't I undo it? Undo. Undo more than once. Even. Ah, no. That compatible. No compatible. Yeah, of course it is not in a. Why is this not working then? Oh, it did work. Oh, thank fucking God. Let's not mess it up now. Okay, so now if it is filled, shit. Yeah, if it is the segment is filled, then what? We need to write this dot index. And if the segment is arg argument, and if it is var, wait, what? What should we pass in case we have a var? Locally, yeah. Great. Okay, so let's try to compile it again. Memory pick one, push. Wait, we're still not getting pop. Why didn't we get the pop? What happened? What the fuck happened? Should have pop local 0 and push local 0, right? But apparently we don't have it. Why? Because maybe we are not getting segment. So let's try to print segment. Let's check the output. It is local. Of course, it is local. Yeah, if it is local, we should have the output, no? Oh, wait. Wait the fuck up. When I call kind of. Oh, okay. We don't even have a bar. I see. So this should not be where, it should be local. And it will work probably. Right? No. You're still not getting the output. What happened now? Right, it is local. Yeah, it is local. And we are writing this, aren't we? Self dot. What? Maybe we don't have the index. Let me check. Yeah, I do have the index as well. What the heck? Wait. Where have I written the code? The compile let statement, right? But this is incorrect. After we have compiled the expression, then we should do all of this shit. Not after, not before. That's the problem, I guess. Let me check. Yeah, it comes here. It should be after this thing. Yeah, we were printing it at in the wrong order. So what should we do now? We need to move all of this code. Yeah, so for the time being, let's. Hey, welcome back, Jang. What did you do? Were you sleeping? Or did you work on anything? So your projects. Yeah, I don't have that many projects, man. Why do you think I'm unemployed? I don't really have a good portfolio. So most of this is related to this course. Compiler, assembler and shit. And other things I don't even think they are projects. You can call it a project. Yeah, all of these are a half-baked project. This one YT Chan, it was a front-end app for managing the subscriptions of YouTube, but I didn't complete it. It was written in React. And this one, resource list, a travel log, no, another. These are not really my projects. So yeah, this is it. I don't really have that many projects, and this was the one web app that I made. It's a complex web app, but right now, because the data where the database was hosted, it moved its platform and I lost all the data. That's why it is not showing anything. No, I don't really have a complete project. That's why I'm not interviewing. That's what I'm trying to do right now. Trying to build a portfolio with good projects. This was one of the good projects, but yeah, it has a Slack bot. Slack is the Slack Discord. You can have channels and so on. So this app talks with the Slack bot. You can create your to-dos like this, and you can have a learning streak. I had good what you can say, good number of users for this app, but I lost the database. I lost all the users as well. I don't have it. Yeah, I know. That's what I'm trying to do, trying to create a good portfolio. Because if I try to interview right now, if they ask me what I have done, I don't really have that many projects to show for it. So that's the thing. Yeah, that only. I mean project. That's what I'm talking about. What's your GitHub profile, Genpon? Yeah, it's this one, right? Your portfolio. You do have a portfolio site. What the heck is this? Memo. Wait, you do have a good number of projects here. A commerce, e-commerce, cheap app templater. And I think you have worked on all of these apps during this 1 month period only, right? Oh, I'm not going to say your name. You do have good projects. And look at the contributions. You have been working whole last year, it seems. This is great. See, you have 1785 total contribution in the last year. Do you wanna check mine? See, only 51 contributions. And all of this is because I committed all of this code. That's why this is here. Is it the quick lint one? Yeah. Did you work on quick lint after that? It's PP? What's that? Profile picture? Yeah, it's me. This is me. Do you want to check my website? This is my website. This is my website. Simple. Simple and stupid. Yeah, well, this is an old pic. Maybe 2 years ago. It was taken 2 or 3 years ago. I don't really remember. And it's the contrast is very much darker. It is hosted on Netlify. It is free, so you can host you can host your static sites for free on netlify.com. And this is hosted on Hero. It's super easy to host static websites on Netlify. You just have to pull the code from your GitHub repository, and it will be live. Let me send you the link. Netlify, this one. I think you can do the same thing in GitHub pages as well. Yeah, right. I've never really tried GitHub pages. I think it is similar to Netlify, right? But I did it a long time ago and I didn't get it out. I mean, both platforms are free, so why should I switch? It takes a lot of time as well. I need to what is this called, a domain. I need to redirect the domain name to that GitHub pages after that, so it takes a lot of time to migrate that way. And the source code for this is not really on GitHub, it is on Bitbucket, so I would probably have to fetch it from there also. Oh, fuck. Space Invaders? No, I don't think so. I have not tried it. Where is it? Ah, you mean the cheapette emulator games? I only tried the Pong one, I think. Didn't try Space Invaders. This is right. So is it functioning fully? Yeah, I think I have your code here. Wait, what? Why do you have different repositories for this? Doesn't it work on the cheapette emulator? No? Oh, okay. Dude, you have worked on a lot of projects this week, this month. I've been working on a single project, and you have created like, you know, 5 or 6 projects, I think, this week. Oh, this is nice. Cool graphics. Let me get the code. Yeah, wait. Yeah, wait up, man. I'm doing it. Just forget to tell you what. What? What did I already knew? Yeah, about that. Yeah, you didn't tell me. Python 3 Pygame. Oh, what happened? Yeah, worked. I don't know. I don't think I have. Doesn't matter. Let me just download it again. Wait, what? It's already okay. All right. I need to install it using pip, but I already have it installed in globally. So let me get out of this. All right, so it will work now. Python. We may not find. I what? Oh, it is trying to find Python 3 in the Anaconda. Pip install Python 3 Pygame. No sudo? Okay. Oh, pretty cool, man. What did you use for this fonts and this graphics? It looks really nice. How do I? Yeah, it does have sound. Maybe you can't hear it because of the music. It does have sound. This is really nice, man. So why the fuck did you say you don't really have any good projects? This is a really nice project. What the fuck? Tic-tac-toe. Yeah, wait. Let me just nail this last one. With an AI. I think you saw me the tic-tac-toe one. And I did try the tic-tac-toe one, I think. You worked on it a few weeks ago, right? I think when you came to my stream for the first time, you showed me the tic-tac-toe one. So let me get it again and try to run it. Okay, yeah, I did play this one. The AI version and the QE version as well. Hangman. Oh, nice. Oh, nice. What is this? Do I have to figure out the name from this? No, wait, it is just the hangman. DFGA. What the heck is this? Edges. Okay, edges. Lamb Y. Toots. Oh, Node.js. Correct. Python. This must be Python. Yeah, I got it. This must be Python for sure. Where's N? Where's the fucking N? Pip. Is this pip? No. What the heck is this? No. Tip. Sit. Git. No, it's not Git. Is this another language? Which language is this? Vim. Oh yeah, it is Vim for sure. Yeah, I got that. Wow, Django. Is it Django? No, it's not Django. What could it be? Docker. Is it Docker? No, it's not Docker. Dip. DSDRDE. Developer. Is it developer? No, can't have repeating characters. Oh, is it developer? Oh, this is really nice. Dangerous. No, all the words are related to tech world, like languages and right, Jan? Do you have any other game that I should check out? You know what? Let me play this some more. I really liked it. Oh, it starts giving us the same name. So maybe you should, randomize this. Randomize the questions. It is not random. It is giving me the same stuff. Maybe, yeah. See, I think it is giving me Python again. I just played it. IDE. How many times is it going to give me Python? It has given me Python like 3 times and IDE twice. And what was it again? Vim. See, for the 4th time I am getting Python now. Not fun anymore. I'm getting it for the 5th time now. You should work on this some more. It annoys people when they get the same question again and again. Maybe don't give people the same question once they have played it, man, and increase the questions. I will add. Maybe you can, you can automate this stuff. You can scrap words from maybe from Wikipedia or something. I don't know, and some specific Wikipedia like related to tech, and randomize it that way so that you don't have to hard code the question. It will be much better that way, right? Nano. Is it a nano text editor? Please tell me it is a text editor, because I was thinking of making one. No, okay. Nice. So what's this one? What does it do? This is a scam. Yeah, definitely it is a scam. Wait, did you have a program where, when there was a ball or something, when it touches the wall, it screams, it makes a sound, that annoying sound? Did you make it, or was it someone else's project? I don't remember. It was written in JavaScript, I guess. I think it was yours. Mamo. What the fuck? It's this one, right? Memo, the one which makes the sound, the annoying sound. Yeah, this one. I hate it. I hate this. Fuck. Don't show it to your recruiter next time. Okay? This is the most annoying thing. Make the window smaller. Yeah, let me try it. I'm probably gonna regret it. Fuck. But once it reaches the highest peak, you don't even hear the annoying part. It just ha 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 ha. So it doesn't annoy that much. Let me make it a bit bigger. Yeah, it clicked. It clicked already. See. Forget. Hit. Ah, you can even move the ball. Refresh. Yeah, no, not again. This is a nice GIF. Dude, you have a great projects and great documentation as well. This is really nice. I really hate creating this empty files. None of my projects have them. Even if they have it, it's just the title, nothing else. I should get good at documenting stuff. Oh fuck, I have been coding for 6 hours today. Wait, try this. Dude, how many projects did you create? You are on fire, you know? Open source what? Oh, nice. Oh, this is really nice. How do I play it? What should I do? Oops. I haven't got the energy. Oops. Really nice. You saw the bar? What bar? This bar. at around the finished. No, where is it? You mean this one? The black one? What about it? You can buy item. Mm. Oh, I fuck this window manager. I hate this window manager. Not for what the. How do you use this kind of sprites? These are called sprites, right? Does Pygame provide this kind of what is it called, image components, or do you have to use the libraries for this UI part, UI components? This I don't really know how to do it. You have to code it. Oh, okay. So I have tried doing game development before. So when I tried it using Unity, in that you had to, get some sprites. So for this kind of player, you have to get different sprites for different things, and you have to provide the code and the animation based on the code, different conditions. Is it the same thing with Pygame? No, it's not. Okay. STL. What's the full form of STL? Is it something along the line of standard something library? Standard data library? Not data, of course. Simple direct media layer. Oh, that's a fancy thing. I haven't heard this phrase before. Simple direct media layer. Hardware abstraction layer. Right, computer games. Oh, nice. All right, I'll see you then. Take care. Yeah, I know. I will drop by your stream if I get up early. If I don't expect me. Look. Okay. Let's fix this and we'll call it a day. I should move this code somewhere else. Where should I move it? After the compile expressions. It should be here somewhere. Yeah, so I can do something like this. Array equal to if token right now false, now I can move all of this code somewhere here. If array not array, and do this, else we'll do something else. Okay, let's check the output again. But this is working as expected. Memory peak pop into local, oh, local 0, push local 0. Nice. Let's check. Let's continue. Does this one work? True. We push constant -1 and pop it into local 2. Local 2 is loop. So nice. And after that we have label main while 1, right? And we push local 2, which is the loop. We not at if go to main while 2. Where's the main while 2? Yeah, it's here. At the end. And well, you know what? We'll check if it works correctly tomorrow. This is it for today. We have completed a lot of tasks. Okay, so this is enough. Do we have any to do? Or what? Don't need this one anymore. Or do we? Yeah, we do need it. Okay, so let me close it. What did we work on today? Compiler objects creation, and what else? Method calls. Let's be specific. Object constructor and a third method calls. We have not completed it, so let's see if this partial. All right, great. Alright, then this is it for today, guys. I'll see you in the next stream where we'll be continuing the compiler again. Have a nice day or night or whatever it is for you. I will see you then. Bye bye.